Uh, Hello everyone. Today I'm presenting my project, a stack rehabilitation and recovery tracking system. This is a platform designed to help patients monitor the recovery process while allowing doctors to track progress and providing guidance. It includes basic features like authentication, a rule-based dashboard, exercise management, and progress tracking. This also includes appointment scheduling, feedback system, and AI-powered assistant. This project is built using HTML, CSS, and JavaScript for the front end, and the Node.js and Express for the back end, and MongoDB for the database. If I talk about the landing page, here is the landing page of the application. It follows modern SaaS layout where first user understands the product, then features, and then workflows. So the hero section highlights the main purpose of the system, followed by feature section. See, this is a feature section uh, explaining key functionalities like tracking, exercises, and appointments. It also the UI also supports dark mode using CSS variables and local storage for persistence. So now the basic structure. If I talk about our main landing page, the basic structure of the HTML is pretty simple. It follows nav bar, hero section, feature section, and then footer. We can also see in the code that it simply follows a navigation bar, then the hero section, then the feature section, and then the footer section. So this structure is built using semantic HTML where sections are modularity. And for the CSS part, styling is handled using CSS variables for theming, and layout is managed using Flexbox and Grid for responsiveness. So if I talk about the JavaScript part of this code, form data, whichever we enter, is validated on the client side and sent to backend and sent to backend, which authorizes the data. And basically, it's a REST API call whenever we see on the login or get started button. It's a REST API call which automatically enables the which automatically takes the two pages, which is the login page and the dashboard page. So this UI uses reusable components, a form of components, and transitions for better user experience. So if I talk about the login page, this this is the login page where users authenticate using credentials. So login page is pretty simple. This login request is sent to basically when we click login, it is basically sent to backend which verifies credentials. And on successful login, a JWT token is stored in local storage for session management. This is then the user is directed to the dashboard. So there's a so if we try to log in now, there's also this a password toggle option which is made using JavaScript where you can see the password, and here emojis are used instead of normal ones. So together, the landing, registration, and login pages form the entry and workflow of the application. So now we talk about the dashboard. So this is the main dashboard of the application. It is dynamic and role based, meaning content changes depending on the user is patient or doctor. So this is the patient recovery page you can see, and on the other hand, at the same time, we can see the dashboard page for the doctor as well. So if we talk about for the patient, these are the statistics. These statistics are fetched from the backend and displayed dynamically, showing key insights like progress, exercises, and appointments. The dashboard data is loaded using an API call on the UI and is rendered based on the user role. So this is all done using JavaScript functions in simple. So conditional rendering ensures views for different for patients and doctors. So like exercises and appointments are generally dynamically using data from backend. So this all is also done using JavaScript. Let me show you the code for it. So here, if you see all the data, but this all the data is basically taken from the backend. Data is converted into UI elements using mapping functions in this program. So here, if we go to the web page again, this chart visualizes user progress over time. So here you can see the user progress over time, and also there is this AI assistant in our code. If you see here, this is our AI assistant, which is basically for the like AI tracking along with it. It communicates with the backend AI API to generate responses and the cyber side. So if we talk about sidebar navigation, it is dynamically generated using the user role as well. So if you can see, it's different for both doctors and patients. This function, so there's this render function or render sidebar function used in our code. This function update navigation links depending on user type. And this dashboard acts as a central hub, combining analytics, data visualization, and AI assistance in a single interface. So the next part, if we talk about are the other modules like exercises, appointments, feedback, profile. So user can. So if we talk about simply progress part, so users can input parameters like user can input parameters like pain level and exercise completion percentage, and this is all sent to the this is all sent to the backend like using the post method of the progress. So this data is sent to backend and stored for analysis. And now there's this if we want to, we can, and there's this table, and this chart basically visualizes a dual data like pain and completion are plotted together like in this graph we will talk about. Then is the exercise section. This module manages rehabilitation exercises. So currently there aren't any exercises assigned to this. From the doctor section, actually, we can assign different exercises to different patients. So here, if we go, we can create an exercise and give it to a particular patient. So exercises are displayed as cards actually with details like duration, difficulty, and instructions. So next is appointments feature. So from here, the patient can actually book appointments. Like, see, we can select the doctor and select the timing and all. And this is a like patients can book appointments by selecting doctor date and time. So this authentication is done using again post method for authentication. The request is sent to backend and stored. Doctors can update the appointment status like confirm or completed. If I select any random time like 5:45 and book appointment, and then the same data will be sent to the doctor. And if we come back to the doctor section and refresh the page, another doc has been come, so doctors can select the status. And the last is our feedback section, which is basically the this module enables communication between patient and doctor. So doctors provide like you can select patient, and doctors provide structured feedback with priority and category. Each feedback includes actionable steps like what can be next steps. Patient can mark these steps are completed. So if we go to the patient section after the feedback, here we all will come and we can complete this. So that this is basically updates progress indirectly in the backend part. And the last section, if we talk about which is our profile section. So this module manages user profile and settings. It displays user identity, including role details, and users can update password and information. And if we go to the code in this profile code, so changes are sent to backend dynamically actually, and all these modules together handle tracking, management, and communication and user setting with the systems. So if we talk about the backend part now, this is my backend server built using Node and Express. So it is connected to MongoDB basically, and middleware is used to handle requests and enables front-end and backend communication. Then I talk about the routes code. This file defines all API endpoints. So router, like you can see different one like routers can register and log in. Each route is mapped with the controller function, and authentication and role-based access are enforced here. So next is our middleware part. This layer ensures security. So you can see the verification part is also here only. JWT part is basically used to verify end user identity, and it restricts access based on the user roles. Next is our controllers. Controllers handle business logic of the application. So like the bicrypt hashing and JWT signing, passwords are hashed and tokens are generated securely. Data is processed and returned based on the user role. And also the AI part, like AI response are generated using Gemini API here. That is also handled in this code. And the last is our database. So MongoDB is used for with Mongoose for schema-based modeling. Each model defines a structure and validation. So a reference is created for the user, like relationship between collections are maintained using references. So this backend flows a layered architecture with routes, middleware, controllers, and database. So this system integrates authentication, role-based dashboard exercises, role management, progress tracking, appointments, scheduling, feedback system, and AI assistance in a complete rehabilitation platform. So that was all the running of my project. Thank you.